Hello and welcome to Short Obsess classes. In this video, I am again going to solve some problems relating to multiple linear regression model. I have already solved from the question 1 to 12. So I will start with the question number 13 today. So what is the question number 13? As the number of explanatory variable increases in the regression model, the value of R square will definitely decrease, definitely increase, will not increase, or definitely will not increase. Now the problem with the R square is that whenever the number of explanatory variables or the number of xi increases, the R square shows the goodness of fit increases. This may induce to choose that definitely increase, but in reality what happens that even if the explanatory variables do not have relations with yi, still then it will show rise in explanatory power when actually there is no change. So rise in R square does not always mean increase in the explanatory power. So as the number of explanatory variable increases, the R square always increase, always decrease, definitely will not decrease, definitely will not increase. Option C is the correct answer. Definitely will not decrease. Moving to the second question, R square equals to 1. So R bar square will be equals to what? If R square equals to 1, R bar square will definitely be less than 1 because R bar square actually restricts the bad relations, restricts bad relations of xi with y. So variables which addition of which does not or do not increases goodness of fit is eliminated, and that is the reason R bar square is less than 1. Moving to the next question, which is question number 15. R bar square can take value of what? 0 to 1, between -1, 1, -1, 0 and less than 1. With the reference to the previous question, the value of the R bar square is always less than +1. As I have already explained, that in the case of R bar square, it restricts the bad relations of xi with y. Therefore, the value of R bar square is always less than R square. This statement is incorrect. Correct depends upon the value of k or depends upon the value of n. This statement is always correct. So option B is the correct answer. Moving to the next question, that in comparing the two model on the basis of goodness of fit, the sample size must be same, the dependent variable must be same, the independent variable must be same, both A and B are correct. While we are comparing between two models, we first check the n, the sample size, and we also check the dependent variable yi, and if these two are true, we can actually compare these two models on the basis of the goodness of faith, that which model is better representing the data. Therefore, these two options are correct, A and B. Both of these are correct. So option D is finally correct. So both A and B above are correct. So option D is the correct answer. Moving to the next question, question number D. The Cobb-Douglas production function is represented by which of this? Now, the standard Cobb-Douglas production function is something like this. Lambda to the power alpha 1 minus alpha. Now, if we want to add an error term with it, that also be in the product form, something like this. So, the model which resembles with this model of Cobb-Douglas production function is this. So, option A is the correct answer. Now, coming back to the last question, which is question number 20. It says if the correlation between y and x2 is 0, that is R12 is 0, then the partial correlation coefficient between y and x2 holding x3 constant would be what? Positive, negative, 0, or any of the above. Now, as we can see, the formula of partial correlation coefficient is R12 times R13, R23 divided by root of 1 by R minus R of 12 square and what of R13 square. Now, from this relation, we can put the value of 0 over here and 0 over here. So, it reduces to minus of 13 to 3 divided by 1 by R13 square. So, if we don't know the value of these terms, we cannot actually identify the value of this. Therefore, any of the above is the correct answer because we cannot determine it just from this given information. I hope these problems are helpful for you guys for the exams, and I have solved many problems and small techniques for this chapter. I hope these videos are helpful for you. Until next time, thank you.